Next problem up, I'm looking at problem number 18. A linear equation with constant coefficients that never gets old. And I'm going to get e to the rt times r to the fourth minus 7r cubed plus 6r squared plus 30r minus 36 equal to 0. So e to the rt cannot equal 0. It must be that r to the fourth minus 7r cubed plus 6r squared plus 30r minus 36 equals 0. Now, I know, let me see if 1 works. If I put a 1, 30, 36, 37 minus 42, 1 doesn't work. That's for sure. How about negative 1? 1 plus 7 plus 6 minus 30 minus 36, that doesn't work. I'll try. One of the first 3 integers work roughly 90% of the time. So if I go for 2, 1, that's r to the fourth, r cubed, r squared, r, and the constant. Let's see if that works. I could use the remainder theorem, which is what I was doing, but in this case, it's faster, I guess, just to do this. That's only me, though. Negative 4, negative 8, that is 20. Nope, that didn't work. How about a negative 2? So again, 95% of the time, one of the first 3 integers work. Negative 2, negative 9, 18, 24. That's negative 48. That is negative 18. That's 36. It did work. Very good. And once I get that, I try negative 2 again. See if that works. Multiplicity are very hard to come about. Negative 11. That's 22. Nope, that didn't work. Okay. So what are the other possible? Remember, the possible rationals are 36 divided by 1. So the next one up, I'm going to try 3. So 2 didn't work again. Let's try 3 and see how that works. 1, 3, negative 6, negative 18. That's a 6, negative 18. Awesome. And once I get it into r squared minus 6r plus 6, I can really factor that. This doesn't factor, no big deal. R squared minus 6r. If it's quadratic, I know what to do. Half of the middle number and square it. That's r minus 3 squared equals a 3. Square root both sides. And r will equal 3 plus or minus radical 3. And I have 3 and a negative 2. It should be 4 solutions because we're looking for all solutions. Reals are complex. So the general solution y equal c sub 1 e to the 3t plus c sub 2 e to the negative 2t. I could list the fundamental set. E to the 3t, e to the negative 2t, e to the 3 plus radical 3t, and e to the 3 minus radical 3t, and any multiples of those will do. And you could put those in any order. It doesn't matter where C1, C2 come in, because when you find those coefficients, the answer will be the same regardless. That would be my general solution. And this is, of course, the homogeneous. What do you think is coming up in section 4.3? The homogeneous and particular. And number 20. They would like us to find the constants. Not a problem, we could do that. Again, a third order with constant coefficients and it's linear. We're going to let y equal e to the rt. I'm going to get e to the rt times r cubed plus r equaling 0. E to the rt cannot equal 0. It has to be r into r squared plus 1 equals 0. R equals 0 or plus or minus I. E to the 0 is 1. Cosine of t and sine of t would form the fundamental set. And y equal c1 plus c2 the cosine of t plus c sub 3 the sine of t would be my general solution. Now I need to find those since they gave me initial conditions. Well, let's see what I need. I need y. Y of 0 is actually c1 plus c2, and that's a 0. I need a derivative and a second derivative. The derivative of this will be negative c sub 2 sine of t plus c sub 3 the cosine of t, and y double prime will be negative c sub 2 cosine of t minus c sub 3 sine of t. And if I take y prime of 0, that would be c sub 3, and that's a 1. I got it. And if I take y double prime of 0, y double prime of 0, that would be negative c sub 2, and that equals a 2. That means c sub 2 equals negative 2. And if I know that c sub 1 minus 2 equals 0, c sub 1 equals a 2, and hence my explicit solution will be 2 minus 2 the cosine of t plus the sine of t. That is the equation that satisfies this with those three initial conditions. '24 is my last problem, and it's a lot of fun if you know what I mean. The same deal. This is a linear equation with constant coefficients. I'm going to let y equal e to the rt. I'm going to get e to the rt times 4r cubed plus r plus 5 equal to 0. E to the rt cannot equal 0. So it must be that 4r cubed plus r plus 5 equals 0. And in this case, the factors are factors of 5 divided by 4, plus or minus, of course. So if I take this and I look at starting with negative 1, if I put negative 1, negative 4 minus 1, okay, good, that works. Negative 1 works. Awesome. If I take negative 1, r cubed, r squared, r, and the constant, bring the first one down, that's a negative 4, that is a 4, that's a 5, that's a negative 5, that's a 0. I don't need to use that anymore because now this is quadratic and I know everything there is about quadratic. R squared minus r plus a number equal negative 5/4 plus a number. Take half of the middle number, which is 1/2, and square it. This becomes r minus 1 squared, r minus 1/2 squared equal. This will be negative 5 over 4 plus negative 4 over 4 is a negative 1. So pretty much what I'm getting is that r equal 1/2 plus or minus I, and the fundamental set would be e to the negative t, e to the t over 2 the cosine of t, and e to the t over 2 sine of t. So my general solution is y equal c1 e to the negative t plus c sub 2 e to the t over 2 cosine of t plus c sub 3 e to the t over 3 sine of t. And now I need to find those solutions. Well, y of 0, starting with that, y of 0 is going to be c1 plus c sub 2, and that's going to equal a 2. I need few derivatives, so let me get the derivatives. Y prime equal, let me see, can I fit it there? Let me fit it here. Y prime would be negative c sub 1 e to the negative 2 plus c sub 2 times product rule. Derivative of the first times the second plus the first times derivative of the second, which is a negative sine of t, plus c sub 3 times the same deal, e to the t over 2 1/2 times sine of t, plus e to the t over 2 cosine of t. I think I wrote t over 3. I meant to write t over 2. We know how that works. And I need a derivative of that as well. Oh boy, this is no fun. Well, what's y double prime? So y prime is actually negative c sub 1 e to the negative t plus, thinking what is the best way to do, you know what, brute force will do. But let me get this. What is y prime of 0? That is negative c sub 1. If I put a 0 here, that's 0. That's 1, 1, plus c sub 2 over 2. And if I put a 0 here, that's gone. That's 1, plus c sub 3 equal a 1. That's my second equation. I need one more. If I take y double prime, that will be c sub 1 e to the negative t plus c sub 2 times derivative of this, the product rule. That will be 1/4 e to the t over 2 cosine of t minus 1/2 e to the t over 2 sine of t minus product rule 1/2 e to the t sine of t minus e to the t cosine of t plus c sub 3 times, and it's going to be e to the t over 4 sine of t plus 1/2 e to the t cosine of t plus the product rule 1/2 e to the t over 2 cosine of t plus minus e to the t over 2 sine of t. And if I take y double prime of 0, let me see what I get. C1, this is a 1/4, that's a 0, that's a 0, minus 1. C sub 2, 1/4 minus 1. 1/4 minus 1 is 3/4. And if I put a 0 here, that's gone. 0 here, that's 1/2. Right? 0 here, that's another 1/2, and that's a 0. 1/2 plus 1/2 is 1. So now I'm trying to solve this equation. I'm trying to solve c sub 1, c sub 2, c sub 3, and a 2. And if I multiply those by 2, negative 2, a 1, a 2, and a 2. And if I multiply those by 4, oh, and that equals a negative 1. By 4, that's a 4, that's a 3, that's a 4, and that's a negative 4. And we know how to do this, right? We could say, let's take twice row 1 plus row 2 in row 2, and negative 4 row 1 plus row 3 in row 3. It's called Gaussian augmented matrix form. That's what you were taught. And let's see how this looks. So the first equation is the same. You did take linear algebra, right? Multiplying this by negative 2. Negative 2 plus 2 is a 0. Negative 2 plus 1 is a negative 1. 0 plus 2 is a 2. Negative 2 plus 2 is a negative 2. Multiplying this by a negative 4. Negative 4 plus 4 is 0. Negative 4 plus 3 is a negative 1. 0 plus 4 is 4. And negative 8 minus 2 is a negative 12. And one step and I'm done. I'll use backward substitutions and figure out what those are. I'll use those two. I'm going to take negative row 2 plus row 3, put the result in row 3. Row 1, unused, unchanged. Row 2, used but not changed. Multiply that by a negative. That's a 1, that's a 0. Negative 2 plus 2 is a 2. And 2, that's a negative 10. So from here we get, let me just make more space. So now I know that 2c sub 3 equal negative 10, c sub 3 equal a negative 5. Backward substitution. I know that negative c sub 2 plus 2 times negative 5 equal a negative 2. So negative c sub 2 equal, this is negative, that's an 8, c sub 2 equal a negative 8. And C sub 1 minus 8 equal a 2, C sub 1 equal a 10, and my solution for this, my general solution is y equal, and let me see where was it, I lost track, y equal, I see it, C sub 1 plus C sub 2 plus C sub 3, that would be my general, that would be my explicit solution. And there's your homework.